Welcome to Brain Vision.
So in this particular case, we have got three surfaces. Here the heat is coming in, and over here the water is boiling. So the temperature over here is 100 degrees centigrade. Here we have got, let's say, T1, and here we have temperature T2. T1 should be the answer for part A. The temperature for the aluminum steel interface, and T2 should be the answer for part B. Now let us concentrate at the aluminum block. So in this particular case, we will be using the formula Q equals Ka over L delta T and time. So we know that we are trying to find delta T, which will be given by QL over KAT. Now, the amount of heat is being delivered to boil the water. So the mass of the water that is getting boiled times the latent heat will be the amount of Q. And then for the area, okay, the area is given, so we can just leave the area and the time together. The mass of the water that is getting boiled is 0.15 kilogram. The latent heat for water vaporization is 22.6 times 10 to the 5. The thickness of the pot is 3.1 times 10 to the minus 3. Thermal conductivity of aluminum is 240. The area is given to be 0.015 meters square, and it takes 4 minutes, so that's 4 minutes times 60 seconds. Now delta T is given by T1 minus 100 degree centigrade. So T1 comes out to be 100 degree centigrade plus, if you calculate this, we get 1.2 degree centigrade. So T1 comes out to be 101.2 degree centigrade. Now for the steel block, we can consider that the delta T prime will be Q L prime for the block, K prime, A, and T. So that comes out to be K over K prime, L prime over L times QL K prime or K A T, and this is what we have found before. So we are going to put the ratios of the thermal conductivities in, which is 240 for the aluminum, and for steel this is 14 times the thickness ratio. The thickness initially was 3.1 times 10 to the minus 3. That is for the aluminum. And for steel, the thickness is 1.4 times 10 to the minus 3 times. This has been calculated before to have 1.2 degrees centigrade. Now delta T prime is T2 minus T1. Delta 2 prime is T2 minus T1. So T2 is something that we want to find, and T1 we already found it to be 101.2 degrees centigrade equals, this comes out to be delta T equals 9.4 degrees centigrade. So we find that the temperature of the heating block T2 is 101.2 degrees centigrade plus 9.4 degrees centigrade, and that comes out to be 110.6 degrees centigrade.